In this video, we're going to talk about something called the standard normal distribution. And the standard normal distribution is a normal distribution of z-scores. Because the standard normal distribution uses the standard deviation as its unit of measure, the standard normal distribution has a mean of 0 because any data value that's at the mean has a z-score of 0, and it has a standard deviation of 1. The normal curve that we looked at in our first video for the week was a distribution of raw data, and that could come from anywhere: height, weight, SAT scores. The standard normal distribution is specifically of z-scores, meaning I take all of that raw data and I standardize it to form a standard normal distribution. Doing this takes normal distributions with any random mean and standard deviation and turns them into one specific distribution of z-scores that follow the standard normal with a mean of 0 and a standard deviation of 1. Now that we're in 2025 and we have technology that's capable of doing calculations almost instantaneously for any distribution with a mean and standard deviation, it's less important to use z-scores than it was in the past. When I took statistics back in the 90s, calculators didn't have a built-in statistics package. So we could not look up probabilities for specific normal distributions with unique means and standard deviations. We would standardize our distributions, convert everything to z-scores, and then use a single table for the standard normal distribution to look up probabilities. We're going to take a look at that in our next video just so you can see how that process works, and the video after that will look at how to do it on our graphing calculators. For now, we're going to focus just on some properties of the standard normal distribution. And the first thing to know is that the standard normal distribution follows the empirical rule just like any other normal distribution. Let's go ahead and use our knowledge of normal distributions to answer some questions. So our first example says, the mean height of 15 to 18-year-old males from Chile from 2009 to 2010 was 170 centimeters with a standard deviation of 6.28 centimeters. Male heights are known to follow a normal distribution. Let x equal the height of a 15 to 18-year-old male from Chile from 2009 to 2010. Then x follows a normal distribution of 170 and 6.28. So we know our distribution of heights is normal, 170 is my mean, 6.28 is my standard deviation. And the first question says about 68% of y values, I think that should say of x values, lie between what two values? These values are blank, the z-scores are blank respectively. So let's go ahead and scroll back up to our empirical rule. And I can see that 68% of my data is within one standard deviation of the mean on either side. So coming back down here to my question about heights of teenage males in Chile, I know that I need to be one standard deviation above or below the mean. In other words, I need z-scores of -1 and +1 respectively. To find those, I'm going to take my mean and I'm going to subtract 1 times my standard deviation, and I'm going to take my mean and I'm going to add 1 times my standard deviation. So 170 minus 6.28 is 163.72. So 163.72, and I'm assuming this is centimeters. And then adding, that one I can do, that's going to be 176.28 centimeters. So 68% of the heights of 15 to 18-year-old males from Chile in that stated time range should lie within these two heights or these two z-scores. The next two questions are similar, except you'll notice that the percentage of interest has changed. For question B, they're asking about what percentage of those heights lie within 95%. And we remember from the empirical rule that 95% is within 2 standard deviations. And for part C, we know that 99.7% of the data is within 3 standard deviations. So calculating these values, we're doing exactly what we did here, except now we're doing it with 2 or with 3. Maybe, if I can get my iPad to cooperate. So we can go ahead and do that on our calculator pretty quickly. 170 minus 2 times 6.28 is going to give us 157.44. And 170 plus 2 standard deviations is going to give us 182.56. So 95% of 15 to 18-year-old males from Chile in this time range are within this height range. For the last, it's the same idea, except we're now 3 standard deviations from the mean. Oh, ooh, Mr. J, that is not how that works. Try that again. There we go. That looks more reasonable. So between 151.16 and 188.84. So the next question says, suppose that an 15 to 18-year-old male from Chile was 168 centimeters tall from 2001 to 2010. The z-score when x equals 168 is blank. And we know how to calculate that. We know that z is equal to our data value minus our mean divided by our standard deviation. So let's go ahead and plug that in our calculator. And we get negative 0. And I'm going to round that to 2 decimal places, so 0.32. So this tells me that the x value, 168 centimeters, is 0.32 standard deviations to the left or less than the mean of 170. So the negative z-score tells me that my data value is less than or to the left. The next one, we're going to work backwards. The next one says we know that the height of this person corresponds with a z-score of 1.27. What is his height? The z-score does tell us that we know that his height is 1.27 standard deviations to the right of the mean because it's positive, and positive means that data value is bigger than the mean. Let's go ahead and take a look at our formula for z-scores. we know that z is equal to the data value minus the mean divided by the standard deviation. So 1.27 is equal to our data value minus 170 divided by 6.28. And I want to solve for x. I want to get x by itself. So I'm going to do a little algebra here. I know to undo fractions, I can multiply by their denominator, because if I multiply this by 6.28 on top, those things will cancel. So let's go ahead and multiply both sides of that equation by 6.28. And those guys are going to cancel. So on the left, I get 6.28 times 1.27. And I'm going to copy that whole number down. I don't want to round yet. So on the left, I get 7.9756 equals x minus 170. And then I know in order to get x by itself, I undo that subtraction with addition. So I'm going to add 170 to both sides. And those will cancel. So I get 177.9, and now I can round. 975 would round up to 98 equals x. So the height corresponding to a z-score of 1.27 is 177.98 centimeters. All right, if you have any questions on the standard normal curve or how to calculate percentages or data values within the standard normal curve, feel free to send me an email or drop by office hours. Otherwise, I'll see you in our next video.